Hello, and welcome to Entangled, the podcast where we explore the science of consciousness, the true nature of reality, and what it means to be a spiritual being having a human experience. I'm your host, Jordan Youkilis, and today I'm joined by Dr. Martin Sweatman. Martin is a professor at the University of Edinburgh at the School of Engineering who has also published research on evidence for the Younger Dryas impact hypothesis and the sacred site Göbekli Tepe, which I consistently struggle to pronounce. In this conversation, we start by discussing why Göbekli Tepe is such an important archaeological discovery. We then discuss the synchronous timing between Göbekli Tepe's construction and the Younger Dryas period, and why the YD period was such an important epoch in our planet's history. Martin explains the evidence supporting the impact hypothesis, which suggests a cosmic impact contributed to the dramatic cooling off of our Earth during the YD period, approximately 12,800 to 11,600 years ago. We then discuss how the Younger Dryas impact hypothesis relates to the broader debate of catastrophism versus gradualism. Then we discuss Göbekli Tepe's vulture stone, the Taurid meteor stream, and the archaeoastronomical alignments at the site. Next, Martin and I discussed comet decay, the geological signals at impact sites across the globe, the lunar cycle, and the Earth of Man. We end the conversation considering what historical sites may still remain uncovered and what Göbekli Tepe could mean for the dating of the Sphinx. Outros for this and all episodes available at entangledpodcast.substack.com. Music from the show available on the Spotify playlist Entangled the Vibes. Please enjoy.
Hello, everyone, and welcome to the latest episode of Entangled. I'm very honored today to be joined by Dr. Martin Sweatman. Martin, how are you doing today?
I'm fine, thank you. Yeah, nice to meet you.
Fantastic. Well, Martin's on today to talk about the Younger Dryas impact theory. But before we get into all that, would love to learn a little bit about your personal and professional background, Martin, and how you got interested in the Younger Dryas impact.
Well, I'm a theoretical physicist by training, and my research is mainly at the sort of interface between chemical physics, physical chemistry, and chemical engineering. And I teach chemical engineering, and which isn't immediately related to the Younger Dryas impact or Göbekli Tepe. But I guess I'm also, I have research experience in material science, so it's related somewhat to understanding the geochemistry at the Younger Dryas boundary. That's how I could contribute to that area. But I'm not an archaeologist or a paleontologist or anything like that, or an anthropologist. But I got interested in this through, I've been interested in quite a while, Göbekli Tepe, since it had been made public. And of course, all the symbols were very mysterious, trying to understand them. But it was really reading Graham's book, Magicians of the Gods, which I think has the key to unlocking the interpretation of Göbekli Tepe. And that's how I really got into it. I'd been trying to understand it, and that then sort of opened the door. From there, we found that we could develop the interpretation of Göbekli Tepe much, much further. In fact, at the moment, I have another paper currently in peer review, which goes even further than the work that's been published already. So, and it agrees and supports with what we've already done. So it's very clear that I think that we've got this correct.
Wow. So maybe before we dive into that new paper in peer review, would love to just, if you could give a little bit of background on what is Göbekli Tepe and some of the history of that discovery.
Well, Göbekli Tepe, it's an ancient site. It's in South Turkey currently. And it's so old that it dates right back to the time when people were just transitioning from a hunter-gatherer lifestyle to a sort of settlement lifestyle. And Göbekli Tepe it appears in the archaeological record even before we see clear evidence of agriculture. And previously it had been thought, this is the sort of archaeological paradigm, that agriculture was needed before larger settlements could form. But Göbekli Tepe suggests that there was a stage before that, of sort of monumental construction. And so that then begs the question, well, what prompted this extraordinary monumental construction that Göbekli Tepe represents? Say a bit more about it. It's a hilltop site. It consists of, well, the ground penetrating radar suggests there are about 20 circular or roughly circular enclosures that are formed by these megalithic pillars. A bit like Stonehenge, but there are 20 of them or more on top of this hill in southern Turkey, and archaeologists have so far excavated about 4 or 5 of these enclosures. Excavations are ongoing. And what they've revealed is these giant megalithic pillars covered in symbols. And these enclosures date to, well, the oldest enclosures date to 9,600 BC, something like that.
Wow. And so you mentioned that only 4 or 5 of the enclosures have been excavated. Are the remaining ones at a similar depth, or are they even lower?
I don't know that we can tell that from the ground penetrating radar. So yeah, we can't really answer that one. I would guess the ones that we currently see are already on bedrock. So I think probably that's where the other ones would be too.
That makes sense. And so are there plans to excavate the rest of the enclosures?
I don't know. There are excavations ongoing on different parts of the site. It's a very large site. So I don't know what the focus is at the moment for the excavators, because between and around the enclosures, there are lots of the large sort of circular enclosures. There are lots of many more sort of square house-like structures. And so I don't know exactly what the archaeologists are focusing on at the moment, the enclosures or these sort of more sort of house-like structures. I don't know.
Sure. And you mentioned that, the dating correlates with the end of the last ice age. It'd be great if you could talk a little bit more about that Younger Dryas period and, what we currently believe happened during that time.
Yeah, so the last ice age, the northern hemisphere is particularly what we're talking about, is started warming gradually. And then there was, for a few thousand years, it got almost as warm as conditions are today, and then temperatures plummeted back down to near ice age conditions for over 1,000 years. That period is the period we know as the Younger Dryas. So it dates from roughly, let's say, 10,800 to about 9,600 BC. That's the Younger Dryas period. Things got very cold again in the northern hemisphere before they abruptly warmed once again. And so the period from the end of the Younger Dryas is known as the Holocene period. And it's that period that's associated really with the development and origin of civilization.
Got it. And so the dating with Göbekli Tepe would indicate it was after the end of the Younger Dryas at the beginning of the Holocene. Is that right?
Well, yes. So the oldest date so far from Göbekli Tepe corresponds to the enclosure wall of the oldest enclosure that is currently excavated. And that date is around about 9,600 BC, roughly. And that date corresponds roughly to the end of the Younger Dryas period, the beginning of the Holocene. But having said that, if you look at this enclosure, it's very well constructed. It's huge. It's extreme. It's well designed. It's clearly not something that someone just got up and constructed one day on a whim. There must have been precursors. There must have been trial stages before this. So there would have been this architecture would have been developing. Who knows for how long? Maybe hundreds of years, perhaps thousands of years. Before that. And we don't know where that would have taken place, whether those other structures would have been at Göbekli Tepe or at another site. So all we can say at the moment is the earliest date for Göbekli Tepe corresponds to the end of the Younger Dryas period. But that style of construction must have been in development for a long time before that.
Mm-hmm. And that's kind of what I was touching on with my question earlier about, what's still uncovered or has not been uncovered rather. Is it possible that some of those enclosures date back even earlier than, the earliest dates we've found so far.
Yeah, it's entirely possible that there are the other 15 or 16 enclosures that we see on the radar. It's entirely possible that some of those are older. It's entirely possible that the pillars that are embedded into the walls of the enclosures that we have excavated are older than the enclosure itself. We suspect that because it's known that the pillars have been moved. So they're not all in their original positions. There are various clues towards that. So if the pillars have been moved, then that also suggests that the pillars are older than some of the pillars at least are older than the oldest enclosure. So again, it suggests that things started before the current date. There's also there's an enclosure just outside of the main excavation area known as Enclosure E. And it doesn't have any pillars, but clearly it did have some because there are still some sockets carved into the ground. So it clearly had pillars at one point. And it's fashioned from the bedrock, so we can see this sort of 20-meter wide, roughly smoothed, polished stone surface, these sockets on it. It was an enclosure. The fact that it doesn't have any pillars anymore suggests that some of the pillars perhaps were taken from it and used elsewhere. So it's difficult to date that, but it could well be older than the ones that we know about. So there's a suggestion there that might have been a precursor to some of the others.
That's interesting. And are there any credible theories as to why those pillars may have been moved?
Well, I think you might kind of expect that in a settlement, because I think it is accepted to be a settlement now, not just a place where these monumental constructions were built. I think it's now thought that people were living there. So if you're living in a place for over 1,000 years, Göbekli Tepe seems to have at least a lifetime of 2,000 years. You're going to refashion, remodel, reconstruct parts of it. So it's not a surprise to see that some of the pillars were moved.
Yeah, that makes sense. And so that dating you mentioned that dates back to something like 9,500 BC. What is the material substance that's used, and how do we date that?
So there's one radiocarbon measurement from a small piece of charcoal, which was found in the mortar of the enclosure wall. So that suggests that is the date that enclosure wall roughly was constructed. But as I say, because of the way that pillars appear to have been moved, it doesn't tell us necessarily about the date the pillars were built or fashioned.
Interesting. And is it correct that we don't currently have a way to date stone, which is what makes dating these ancient sites partly so difficult?
Yeah, exactly. I mean, there is a less precise way of measuring some kinds of stone that have quartz crystals in them, that their age, or at least the time since they were last exposed to light. It's some kind of photoluminescence measurement method. It's not as accurate as radiocarbon, and it's not. You have to have the right circumstances to be able to measure it. So you need the right kind of setting to make that a useful measurement. So it's not quite true to say we can't measure the age of stone. But actually, even then, what you're talking about is the time since that stone was put in place. It's still not actually telling you when that pillar, for instance, was actually made.
Yeah, that's a good point. Interesting. So going back to the Younger Dryas period, could you talk about why was that such an important period in the history of our planet, and what do you think could have caused it?
Well, it's very interesting, I think, largely because it's associated with the origin of settled life, which I would say is the origin of civilization. I kind of equate the two things. So we see once this climate had improved after the end of the Younger Dryas, conditions in the northern hemisphere had improved. There was more land available for agriculture. We see that this is when settlements really started to grow and people's way of life changed. So that's, for archaeologists, that's the really interesting thing about it. From a geological perspective, we have this period of about 1,200 years when climate abruptly changed. And the beginning of that period there's been a lot of debate about why suddenly in the Northern Hemisphere climate dropped so rapidly. And there is a prevailing theory, which is very popular, which is that massive outflows of fresh water from the northern ice sheets, for whatever reason, there are these massive outflows of fresh water into the northern oceans, and that would then prevent ocean circulation. That would tend to then cool the northern hemisphere. But understanding why these large outflows of water from the northern ice sheets happen is where there are some question marks. What triggers that process? Are they always entirely natural, these large outflows, or can they be triggered by, for instance, a cosmic impact or some other process? So there's a lot of debate about the exact cause of this Younger Dryas period.
Interesting.
But generally, I think it's accepted that these massive outflows of fresh water from the ice sheets is the sort of the main mechanism, but it's kind of what triggers them is the issue.
Yeah, and it seems like the idea that it was a cosmic impact has been gaining steam amongst a lot of scientists over the last, 15 years, but that's maybe the main point of contention. Is that fair to say?
Yes. Yeah, so there are lots of things happening at that point. So as well as this dramatic change in climate, there seem to be changes in, particularly in the Americas. There's this thing called the end of Clovis, which looks suspiciously close to that period, this change in climate. And there's a whole bunch of extinction. So it's referred to as megafauna extinctions. Now, across the last 40 or 50,000 years of the last ice age, data suggests that there were extinctions across this period, but there seems to be a particularly dense cluster of extinctions right at the beginning of the Younger Dryas. So that's another sort of, it's too much of a coincidence. You've got all these extinctions, you've got this climate change, you've got changes in human population. And so then scientists investigating what's known as the Younger Dryas black mat found that, which in terms of radiocarbon age looks to be very close to the onset of the Younger Dryas. They found that there are lots of geochemical signals for a cosmic impact right at the base of that black mat in lots of different locations. So that's when that was published, that's when the Younger Dryas impact hypothesis took off. And I think it has been gaining ground. Certainly, as I see it, the evidence is extremely strong. It's also had a lot of opposition from some, particularly from some quarters. I wouldn't say that the whole science community is against it, but that there are certain quarters, certain parts of the scientific community that don't like the idea, despite the incredible evidence that's in favor of it.
Yeah, and I think this debate really gets back to a larger discussion of the whole idea of catastrophism versus gradualism. So maybe you could talk a little bit more about the history of that scientific thought.
Yeah, I find it because my background is not in geology, it's in physics and chemical engineering. I find it a bit perplexing as to why there is this great resistance to this idea. It seems like a perfectly natural idea to me. We see, astronomers now know that there are all these objects in space. If you look even further out into space, we see all these large icy bodies, and we can predict their orbits, and we can see that at some point, some of them will enter into an Earth-crossing orbit. So we expect to see cosmic impacts like this. It's just a case of how often will they occur, and there's some uncertainty about that. So it seems like a perfectly natural process, and yet I think if you've come through the education system, maybe from a more of an archaeological or geological perspective, there tends to be this resistance to the whole idea of cosmic impacts. That I suspect from an archaeological point of view, they want to see the sort of motivate, the sort of the mechanisms for everything to be found, in the ground, so to speak, in terms of everything's to do with people's behavior and civilizations. And so an astronomical explanation for what they observe at some of these sites is perhaps not what they, perhaps less interesting to them. I don't know. But from a historical perspective, there has been for a long time a debate between catastrophism and what we might call gradualism. You can take it back to the classical philosophers back in ancient Greece. So Plato talked about faith on myth and even Atlantis. And whereas Aristotle, a student, was talking about, the universe or the planetary bodies are carried on these these impermeable spherical on these spheres that rotate around the Earth at the Earth's center. So and these things never change. So you've got these different viewpoints, and then you come forward. You have the Enlightenment and the scientific revolution, and again, there's debate about whether cosmic impacts could happen, or whether how to explain abrupt changes in or the observation of fossils in the ground and how they seem to occur at different levels in the sediment and so on. So there's been for a long time there's been a debate, and I think probably from about the 1800s, some geologists, Hutton and Lyell, they kind of won out for a while their view that processes happen relatively slowly on Earth. And then Darwinism came along and also suggested that processes were, evolution was relatively slow. So we didn't need any kind of catastrophism. But as I say, with changes, with advances in astronomy, with looking much more closely now at the fossil record, we can see that things have been pretty catastrophic in Earth's history. So I think it's now, catastrophism is now generally accepted. The difficulty now, I think, is with accepting that there is another kind of cosmic impact that doesn't necessarily form craters. So these are air bursts. They're much harder to interpret. They're more difficult to detect because the signals they leave behind, you need much more advanced scientific methods to detect them. So, and again, rather than these impacts being caused by asteroids, which we can easily see, they tend to be caused by, let's say, comets or comet fragments. And, astronomers have known about the asteroid belt between between Mars and Jupiter for a long time, but we're only, I think, getting an understanding of comets and their behavior more recently. So it's all coming up. I think it's adding up to a much better picture now. But I think just for historical reasons, there's a lot of resistance to these new ideas.
Yeah, it's interesting. And it's one of your papers you talked about that kind of time period of the Enlightenment, of the Copernicans, and their issues they had in getting people to accept heliocentrism. And it feels very much like we may be at a similar paradigm shift in our understanding of the history of geology and of the planet.
Yeah, I think so. I think there is. It does require quite a big change, and I think opposition to these changes is not always based on the science. I think that quite often the voices that are opposed to this have other influences that are not just scientific, sort of political or religious opposition. But as a scientist, I just stick to the science.
Yeah. And you mentioned obviously Graham Hancock's work earlier, and you were featured in his Netflix documentary series, and he kind of touches on some of those dynamics a lot too. I'm curious, was that your first Netflix feature?
Yes, first Netflix. I do actually have another program out. I feature in another in another TV program. So it's called Forbidden History.
Okay.
Season 7, Episode 3, Secrets of Göbekli Tepe. And that focuses more on really Göbekli Tepe and the Younger Dryas impact and sort of my ideas. So it's more focused. And that's a really good program as well. It's not out. It's out in America, I think, in the US on Discovery Science Channel, but it's not out.
Awesome. We'll have to check that out. Yeah. And you were, I believe, also at Göbekli Tepe with Graham on Ancient Apocalypse. And in particular, I think you guys were talking about the vulture stone. So we'd love to hear a little bit more about, why that's such an important part of the structure.
So at Göbekli Tepe, there is one of these enclosures called Enclosure D. And the vulture stone is one of the pillars. Well, they call it Pillar 43, the archaeologists. So it's one of the pillars there. It's probably the most intricately carved of all the pillars. And lots of symbols to interpret. And so we previously published a paper back in 2017. This is with a colleague, where we interpreted the symbols on the pillar as giving a date. So essentially a date stamp using precession of the equinoxes. Now, supposedly, precession was first discovered by Hipparchus in the 2nd century BC. So this is 10,000 years before that. It seems that precession was known and used to represent dates. So that's a bit controversial.
And what is precession of the equinox?
So the Earth obviously rotates on its axis, and that axis points to a point in the sky. We kind of associate that with a pole star. But over 26,000 years, this axis precesses. So the Earth's rotational axis points at a different point in the sky. And that draws out a circle over 26,000 years. And the consequence of that is that if you look on the summer solstice, if you try to estimate which constellation is behind the sun on the summer solstice, that also changes over 26,000 years. So it'll go through an entire cycle of the zodiac in 26,000 years. So if you draw a picture of the sun on the summer solstice relative to the constellations around it, you can use that as a way to write a date with a period of roughly 26,000 years. On the other hand, if you just say, well, the sun is nearest to this particular constellation on the summer solstice, you can also write a date, but with less accuracy, because you're just saying, well, it's near that constellation rather than saying exactly its position relative to it. But then you can use the other constellations on the equinoxes and the winter solstice to refine your date. So there are different ways of doing this, and we can see that people have used different ways, we think, to write these dates. Now, on the vulture on Pillar 43 at Göbekli Tepe, they've actually used the sun in a relative position to what appears to be a constellation similar to Sagittarius. So they've used this directly, the position of the sun relative to a constellation, to write this date. And that date, if you take this particular symbol, this sort of eagle or vulture symbol to represent what we call the teapot asterism, which is essentially the bow of Sagittarius. If you take that as what it's representing, and the date we get from that is very close to the Younger Dryas impact. So it seems to us, or we can interpret this pillar as being a memorial to the Younger Dryas impact. At the bottom of the pillar as well, there's a little headless man, perhaps indicating death. And of course, you've got to explain, why did anyone build such an amazing construction at this time? They were hunter-gatherers. Rather than gradually sort of developing their architecture, instead what's happened is they have these amazing monuments which are completely unexpected. And then you have to ask, well, why did they do that at that time? There has to be a strong motivation. And I think the Younger Dryas impact gives you the sort of the required motivation to build these amazing structures. Essentially, what I'm saying is that possibly the impact inspired a religion or a new religion. And it's this religion that then motivated the building of these monuments.
Interesting. So also, like, as a way to kind of memorialize the beginning of that religion or era or whatever it reflected.
Yeah, so we think it could be memorializing the event, and and after a while, this event inspired a religion. And, then you start building your cathedral, whatever it is, for this religion. There's also another pillar 33, which shows some of the same animal symbols, which we think are constellations. And projecting out of these animal symbols are snakes. And then, so if you think of these animal symbols as being constellations, then the snakes are a really nice picture of probably meteors. And we can even work out which meteor stream this might be, because we think we can recognize which constellations these animal symbols correspond to. And it appears that this meteor stream that's represented on this pillar is the Taurid meteor stream, because of the constellations it's radiating from. And the Taurid meteor stream is the same meteor stream that's been implicated in the Younger Dryas impact. So we've got separate corroborating evidence. Now, in this latest paper I mentioned, a manuscript that is currently in peer review, we have an interpretation for some other symbols on these pillars. These are V symbols. Excuse me. And what we can see is that on pillar 43, there appears to be an entire lunar solar calendar encoded in V symbols. And so you can kind of count the number of V symbols. And what you find is that you have 364 of them, or you can find a way to make 364 of them. You're missing one, but there is one more V symbol on the neck of this eagle or vulture, which we think represents the summer solstice. So that would agree, this is another day, 365 for the lunar solar calendar. And again, as you look at pillar 33, we predicted that pillar 33 represented a meteor stream, the Taurid meteor stream, which would have radiated for several weeks from these different constellations. On that pillar, we see these V symbols, and there are, if you count them, 13 of them indicating radiation from one constellation and 14 from another. So in other words, for about a period of a month, it appears that they were observing the meteor stream. So it all ties together. Now we have an interpretation for these abstract V symbols as well as the animal symbols that all basically mutually supports each other.
Interesting. And could you talk through where is the Taurid meteor stream, and how do we today interact with it?
Well, today we observe it from the direction it goes from Pisces through Aries to Taurus, which is why it's called the Taurid meteor stream. And so that's the sort of the radiant position in the sky that the meteor stream appears to radiate from. Yeah, and it goes through those constellations. And that takes 6 to 8 weeks, I think, currently. Now, because of precession of the meteor stream, not Earth, I'm talking now, because of precession of the meteor stream, 12,000 years ago, it would have moved along the zodiac by 2 constellations. So back in Göbekli Tepe, it would have radiated from the position, let's get this right, of, initially Capricornus, and then Aquarius, and then Pisces. And that's what we see on some of these pillars, that the pillar that I mentioned, with the snakes, it seems to be representing Aquarius and Pisces. So that's how we associate it with the Taurid meteor stream. So it's due to precession of the longitudinal precession of the Taurid meteor stream that things have changed.
Interesting. And so is the idea that one of these big meteors from this stream would have hit at the beginning of the impact, at the beginning of the Younger Dryas period, or are we not that refined yet?
That's the idea. I mean, we know that the Taurid meteor stream would have been much more active, let's say 10 or 20,000 years ago. It's a very big meteor stream. It's mostly decayed. It's a very old meteor stream, I should say. So it would have been much more intense back then. So it's like the main culprit. But actually saying we can prove it, we can't prove it, of course. Yeah. However, at Göbekli Tepe, we seem to have a witness statement, if you like, which says it was the Taurine meteor stream that did it. That's how we interpret those symbols anyway.
Yeah. And so then what do we think it is that caused the end of the Younger Dryas period, Meltwater Pulse 1b?
So the end period, I think, is also, that's a good question. I think that would have been a reversal of the cause of the Younger Dryas, I guess. So, I mean, these things aren't well known. So you have what started the Younger Dryas period. The main hypothesis is that it was these massive outflows of fresh water, melting of the ice sheets that would have caused some kind of disruption to the ocean circulation currents. There's massive ocean circulation currents that transport heat all around the planet. So then if you're saying, well, what ended the Younger Dryas, probably it's a resumption of those massive ocean circulation currents. So the salt-free water that was blocking the Atlantic current presumably had dispersed, had warmed up, and so that Atlantic current was free to begin again, and therefore you kind of restart, or you kind of reset your ocean circulation currents, and so then things warm up again in the Northern Hemisphere.
And obviously Graham's thesis is that there was an advanced civilization prior to this period, and that seems to possibly be one of the reasons why some in the scientific community have resisted the Younger Dryas impact hypothesis, is that maybe if they accept it, then it lends more credibility to the idea that there was a high civilization, before this happened, potentially Atlantis. What do you think about all that?
Well, I personally don't see a need. I don't see any strong evidence for a civilization before the Younger Dryas event. I'm pretty sure there couldn't have been an advanced civilization. It depends what you mean by advanced civilization. Because if there was such a thing, it would show up quite easily in the archaeological record, and I don't think we see that. I think it's possible, and there could have been maybe a sort of fledgling Stone Age civilization, by which I mean people settling down into communities, building towns, but still Stone Age, still very limited. And it's possible that such a civilization could have been destroyed or submerged under the meltwaters. But again, that's speculation. I don't think we see any evidence for that yet. But for an advanced civilization, I don't see that as being. Well, I think that's very difficult, because I think if such a thing had existed, evidence would be obvious, and we just don't see it.
Interesting. So you think like there would have been more material evidence or the like left over?
Yeah, material evidence, definitely. Yeah, I mean, you would see the material evidence wouldn't just be confined to those areas that are now submerged. You would see it much more widely dispersed. But also, I think particularly genetic evidence. If there was, let's say if there was an advanced civilization, I think they would be trading, they would be colonizing, they would be moving around the earth. And so we'd see plants and animals and people, their genetic remains, their profiles crop up in unexpected places. And again, we don't see that. So I think if there was anything at all, any kind of civilization at all, it'd still need to be quite limited, probably Stone Age, not a trading civilization, perhaps an exploring civilization. But again, this is speculation. I personally don't know of any evidence really, or any strong evidence to suggest such a civilization existed. But I think it's within the realms of possibility that a fledgling civilization could have existed before the Younger Dryas.
And just to push back on the genetic markers piece, I believe that Graham's last book, he highlights some similarities between Aborigines in Australia and natives in the Amazonian rainforest that were pretty anomalous.
To be honest, I'm not an expert on Graham's books. I can't really.
Sure.
The details.
Yep. No, that makes sense. And it's interesting to me too that, there's the resistance to the Younger Dryas impact when, it seems like the whole idea of the dinosaurs and their extinction by comet impact was similarly rejected until we find the crater impact. So it's interesting to me that there's still this resistance to the idea of cosmic impacts causing massive, global change.
Yes, yeah, there is. Now, as I say, I think there's possibly historical reasons for that, the way that the geological sciences have developed through the centuries. So this gradualist or uniformitarian principle was very strong. And, I think we've only really become aware of what's out there in space over the last few decades. So, and I think, as I said before, I think there's just a reluctance to accept that things outside of the Earth are responsible for some of the changes that we see, especially if they don't leave craters. This is the new thing, you see. If you don't have a crater, then how can you know there was an impact? I think scientists have got used to the idea of crater-forming impacts, but non-crater-forming impacts, I think they're much harder to identify. But we know they happen. I mean, obviously, that we see things in space that will generate these kind of impacts, so we know they must happen. We know about the Tunguska impact. There have been other reported air bursts as well in history. So we know these things happen. It's just, well, how often do they happen? And particularly, I think there's an issue with the current estimates for the rate of impacts are based largely on what we currently see in the sky. And there is an assumption that things don't change, that what we see in the sky now is kind of what's always been in the sky. But if you factor in this this more recent mechanism that comets from the outer reaches of the solar system can find their way into the inner solar system and decay, well, that process only takes a few thousand years. So you have to factor in, well, the sky could change, what's out there in space in near Earth orbit, that could change dramatically on the order of a few thousand years. So any estimate we have right now, based on what we see right now, that could, on the one hand, that could change completely within a few thousand years, but also it's not a reliable way of predicting what the sky looked like, let's say 20,000 years ago.
Yeah.
Particularly because we're talking about comets, and comets decay when they get into the inner solar system. All they leave behind, they leave behind meteor streams. So that's one way that we know that these comets have decayed in the inner solar system. They leave behind meteor streams. Now they also and those meteor streams will gradually decay to smaller and smaller pieces, eventually to dust. And so we see the zodiacal dust cloud, which is this diffuse dust that permeates the plane of the solar system, or the inner part of the solar system. And so if we look at how much dust there is in the inner solar system, again, that indicates that there was very likely a giant comet that entered the inner solar system maybe 20, 30,000 years ago and has since decayed. So there are some good clues for this scenario. But again, they seem to be, despite the evidence, they seem to be resisted, or they seem to be controversial. But I find the evidence to be very convincing.
Yeah. And I think all the evidence you put together in your paper, compiling it all was super compelling. And you talk about obviously not having the crater impact, but I think one of the things that's so compelling is how there have been all these different sites that have appeared across 4 different continents. Maybe you could talk about, what that correlation and timing really does to support the evidence.
Yeah, so there's been a lot of work, dozens of papers by very detailed studies of sites around the world. Well, I say on 4 continents at least. So these are studies of the geochemical signals of cosmic impact, and they seem to occur at what's known as the Younger Dryas boundaries. This is when the event is thought to have happened. At the base of often at the base of what is known as the Younger Dryas black mat. So this is like a layer of discolored sediment, which occurs, it seems to occur now across many continents. And so sometimes this Younger Dryas black mat is enriched in charcoal, and you can say, there looks to have been some massive wildfires. Other times, this black mat is just indicating a change in climate. But at the base of this discolored sediment, there is this quite often a thin layer of charcoal or soot, and that is sort of mixed with these geochemical signals for impact. So we're talking about nanodiamonds, impact microspherules, melt glass, and platinum group metals, particularly platinum. And this is found, if you see these indicators of a cosmic impact widely dispersed across, let's say, at the moment, about half of the Earth's surface, with radiocarbon dating all roughly to about the same time, within the uncertainty of the measurements, then it's natural to say, well, there was this giant event that occurred. What other explanation is there? And so that's why I think this is basically confirmed now. There is so much evidence. In fact, there's another paper, a review paper by James Powell, and with the title which begins "Premature Rejection of the Younger Dryas Impact Hypothesis." So in his paper, he has a nice table of, I think there are something like 56 different sites now where they have, in fact, I can just got it here. So he has a nice table. There are, it's got about, so he's got a list of all the different, of the main impact indicators at these 56 different sites. And so they find the black mat at 30 of them, impact spherules at 34 of them, melt glass at 10 of them, nanodiamonds at 26 of them, platinum group elements at 38 of them, and fire markers, so that's charcoal, so at 39 of them. So, 56 sites across 4 continents, you have all of these impact markers. It's really convincing for me.
Yeah, and I'll make sure to add a link to that paper in the show notes.
Good, thanks.
Yeah, absolutely. And you mentioned, the nanodiamonds and microspherules and all that. Are those indicators of something that does not typically happen on Earth without a cosmic impact?
Some of them are not completely diagnostic of a cosmic impact. So let's say it is possible volcanism. So volcanoes can release platinum group metals in greater abundance than you normally find in Earth's crust. And that's because the interior of the Earth is richer in platinum group metals than the Earth's crust. So volcanoes can release those metals, but in that case, you'd also expect to find enrichment in sulfates, and you'd expect to find volcanic tephra, and we don't find these at all. So it's the platinum group metals in the absence of other indicators of volcanism, plus other indicators of a cosmic impact, like melt glass, for instance. Studies at some sites have shown that melt glass can only have formed above 2000 degrees Celsius, and volcanoes don't produce such high. Volcanism doesn't produce such high temperatures. So again, that rules out volcanism. Nanodiamonds, not thought to be generated by volcanism, but they are known to be carried by meteorites, and they're known to be generated by high energy explosions involving a carbon substrate. So nanodiamonds points to cosmic impact as well. And the impact spherules, or at least the microspherules, we think the thought is that these are impact microspherules, in part is because many of them are enriched in metals, so iron and other metals. And again, you wouldn't expect that from volcanism. So there are, if you look at it sort of diagnostically, which is what the researchers have done very carefully, they have diagnosed essentially a cosmic impact through the evidence.
Wow. That's wild. It's really exciting stuff. So I'm curious, you mentioned, you've got a paper right now in peer review. Where do your interests take you next? Are you still focusing on Göbekli Tepe or any other areas of interest these days?
Yeah, so my main focus really has always been Göbekli Tepe. And of course, because our interpretation about that is related to the Younger Dryas impact, I then have a very strong interest in understanding the Younger Dryas impact. So that's what led me to write that review paper. But as I said, we have a manuscript So this was, I say we, I was contacted by a guy, John Gordon is his name, out of the blue. And so it was really his insight. He had been looking at Pillar 43 at Göbekli Tepe, and he had noticed that these V symbols seemed to be indicating some kind of lunar cycle. And so from that initial insight, then went on to develop this whole interpretation of the V symbols at Göbekli Tepe and at other sites. But we see there are V symbols also on the Urfa Man. So the Urfa Man is it's a very well-known statue in that area that dates to around the time of Göbekli Tepe. It's the first sort of large human-sized statue ever made. And again, he has a double V on his neck. And previously, the explanation for this double V was that, well, it looks like an item of clothing, perhaps, like a V-neck jumper. But we see these V symbols elsewhere, and we can interpret them as indicating days. So we interpret the V at the neck as indicating, well, this is a deity with some kind of control over time or a creation deity. And that, I think, fit very well with this whole notion of this being a religious icon, essentially.
Yeah. And that would be logical, right? If, there was this massive comic impact, obviously, then it disrupted their, been a meaningful moment in their society.
Yeah. I mean, with religion, prominent religions, you expect deities, icons of the deities to exist. Yeah. Created deities, time-controlling deities. And the other very interesting thing as well in this paper is that we try to make some links between the symbolism we see at Göbekli Tepe and the symbolism that we see much later in the Bronze Age in that region, or in Mesopotamia, Egypt, and beyond. And there do seem now to be very clear links. There does seem to be a continuity of symbolism from the time of Göbekli Tepe through to the Bronze Age. So we're starting to see really strong connections now, symbolically.
Wow. And am I correct that there's other sites near Göbekli Tepe, like Karahan Tepe, and that it's actually even a larger, potentially multi-site structure? Or how should we think about the relationship between those?
That's right. So in the last year or so, the Göbekli Tepe has been put into a sort of better context. So archaeologists in that area have uncovered about 12 other sites.
Wow.
Karahan Tepe is the most well-known, and it's the most similar so far to Göbekli Tepe in that it has similar style T-pillars, these pillars that we're talking about, and it has similar kind of carvings on them. In our latest manuscript, we suggest they were using the same lunar solar calendar as well, because, this is getting into details now, but for a lunar solar calendar, 11 turns out to be a special number. 11 is the number of days after you've counted all of your lunar cycles. 11 is the number of days left that you need to complete a solar year. 11 plus 1 is also the number of lunar cycles. So 11 is kind of like a special number for a lunar solar calendar system. And it turns out that the two biggest enclosures at Göbekli Tepe have 11 pillars. And there is a special structure at Karahan Tepe, which has 11 pillars. So it seems that they were using the same calendar system.
Interesting. So it seems like the calendar was obviously very important for them. I mean, why could that have been such an important thing to memorialize?
Well, I mean, if you think about life, try to think about life back then, it would have been so dominated by the seasons. Everything, all of your resources is dominated by the seasons. It's going to influence how you manage your life, having a family, how you forage for food. Everything is dominated by the seasons. And the seasons can be tracked, they can be marked, they can be followed by following, primarily the sun and the equinoxes. But tied into that, if you're counting days, you've got the moon, which has a regular cycle. So for me, it's kind of obvious that ancient people would have been really interested in astronomy, the moon and the sun, the equinoxes, but also the stars, because we have so many things to entertain us. we'd hardly notice the sky. I think in his Netflix program, Graham gets the spot on. People were much more interested in the sky back in ancient times. We see many cultures, ancient cultures that we know were interested in astronomy. They built their religions around astronomy, so Mesopotamians, the Egyptians. So we know it was a key influence. And if you just take that back further, people must still have been interested. Their lives had been dominated by the seasons and therefore astronomy. So it all makes, I think, sense.
Yeah, that totally makes sense. And you bring up the whole light pollution issue. I mean, it's fascinating. Even just going camping, like to try and get away from it, to see where you can really get a clear view of the stars is almost impossible these days, at least in the West.
Yeah, but when you do, it's fantastic, isn't it?
Yeah.
When you get a really clear view of the sky, and you have to travel a long way to the middle of nowhere into the wilderness to get to such a place, then you really see the sky, and it's just fantastic.
Yeah. And, I think one of the really interesting things about Göbekli Tepe, I mean, there's so much that's so interesting about it, but one of the other things is that it appears to have been intentionally buried at a certain point. I'm curious, do you have any theories about when and why that would have been?
Yeah, so this was something that was suggested originally by, let's say, excavators maybe 10 years ago, that the site was intentionally buried. I think the view on that has changed. More recent excavations suggest that this, at least a lot of the filling may have just happened naturally, because the suggestion is, at least, you have these enclosures, these sort of ceremonial spaces that people were frequenting and keeping well ordered. But around that, you've got life going on. You've got people building houses, and they would just rebuild houses on top of each other every few generations. Let's say that you get a new house, you build it on top of the other one. And you have these houses piling on top of each other, and after a while, they completely overlook and overcrowd the enclosures that they're built around. And then there's a suggestion that at some point, maybe an earthquake, perhaps bad weather, the things just collapse in and just sort of bury these enclosures. So I don't think the idea now is that these were deliberately buried, or at least initially there may have been some basically landslide. But once these things had become partially filled, maybe then there was an attempt to give them a more decent burial, if you like. So it may be in a combination of that.
Yeah.
Because if you look at other archaeological sites, it seems to be it's a well understood practice that houses seem to have a lifetime, that the houses that people lived in, they lived for a few generations, and then when it was time for a new house, they built directly on the previous one, and they kind of almost like buried the previous house as though it was a person.
Wow. That's wild. And, it's interesting talking about how much is still buried. I just got back from a trip to Egypt where, our guides were telling us about just, they know there's just so much that's still to be excavated, probably vast more than has been uncovered. So I'm curious, are there any other sites around the world that you find particularly interesting, or any areas you think archaeologists should be looking that we're maybe not looking today?
Well, yes, I suppose. Göbekli Tepe through to the Bronze Age, we're seeing this symbolism. So presumably this symbolism must have existed continuously across that period. And so we should expect to find evidence for this symbolism in the intervening settlements. So I'm wondering, I think it would be interesting to try and find evidence for this symbolism sort of continuously across this period. So that would involve further excavations, studies in the region of Mesopotamia, in Iran, and also Egypt, trying to link the symbolism in this very long period between Göbekli Tepe and the Bronze Age. That's one interesting area, I think. I think Graham is probably right. There's bound to be some interesting sites, I think, that are currently underwater. We know nothing about. So there's a lot to be discovered, I think, under on the sort of the coastal margins.
Yep, that makes total sense. Interesting. And when you talk about the symbolism, are you talking specifically about looking for calendars or other types of like archaeastronomical alignments that date to the specific date, or other symbols as well?
Yes. So I guess all of the above. Any kind of archaeoastronomical, I can't even say it myself, archaeastronomical symbolism. So zodiac particularly, is there a continuation in these animal symbols? I don't think that's been very well studied, because I think the assumption is, well, they're just animal symbols, they're pictures of animals. And so why would there be any pattern to them? But I think if you then think, well, maybe some of them are art, but maybe they're sort of the ones that have like a religious context. Perhaps those are zodiacal symbols. And then, is there any way to, or how can we understand symbolism or notation for a calendar system? That's not obvious either. Because you're looking at markers, you have to then sort of count marks, if you like. And so you have to then kind of be able to recognize, well, that's because people would not have used the same calendar system that we're using today. Obviously, they have their own calendar systems. It seems that they're way back at Göbekli Tepe, they had a lunar-solar one. So does that continue?
Yeah.
And again, I think the assumption has been that this just wouldn't have existed, and therefore it's not been looked for. So we know for Stonehenge, for example, again, megalithic monument. It has very clear alignments towards the solstices. There's been a paper published recently which suggests it too, its pillars were also a calendar system. So this seems to be a pattern that many these megalithic circles seem to be related to calendar systems. We see the same thing in the northeast of Scotland. There are these, they're called recumbent stone circles, but again, they seem to be calendar systems.
Interesting. And are they similar lunisolar calendar systems that have that 11 that you're talking about, or is that unique to Göbekli Tepe?
So, well, okay, Stonehenge doesn't seem to be of that type exactly. So Stonehenge seems to be using an early Egyptian type of calendar, which is where you have 12 months of 30 days exactly. And so therefore, rather than 11, you only need 5 days to complete a solar year. And so that at Stonehenge, there are these 5 pillars in sort of the inner circle of Stonehenge. And so that's how you have 30, it seems, around the outside, and then 5 in the middle. So that it's a different kind of calendar. It's a solar calendar, but I wouldn't call it a lunar solar calendar because it doesn't respect the lunar cycle closely. The stone circles in the northeast of Scotland, they typically have 11 or 12 pillars. So again, they might have been using a mix of calendar systems, but the problem with those stone circles is they're often not very complete. So there's relatively few that look to be in good condition.
And do you think that's just due to, the weathering of the ages and people throughout time kind of tearing it apart and all that?
Yeah. Farmers, people looking for construction materials and so on.
Gotcha. Yep. Interesting. Which I think, again, is why Göbekli Tepe is so unique, because it's so massive and in such pristine condition.
Yeah, because it was hidden, it was buried. It's remained intact, which is brilliant. Absolutely brilliant for us. Yeah, but as you say, other sites haven't fared so well. But it does make you wonder, if you go back to the time before Göbekli Tepe was discovered, it would not have been thought that such a site existed, or was even possible, perhaps. Yeah, so it was a complete revelation when it was discovered.
Yeah. And
so you think that makes you think, what else could be out there?
Totally. Well, and I think it also, to your point, right, lends a lot of credence to John Anthony West and Robert Schoch's proposal that the Sphinx may be older than we believe because of the water weather dating. So I'm curious if you have any thoughts on what this means for the Sphinx.
Yeah, I mean, in my book, I speculated that the Sphinx might be another one of these zodiacal symbols related. Well, in my book, I thought it might be related to Cancer rather than Leo. But that was quite speculative. And the dating of the Sphinx, the sort of scientific evidence for dating of the Sphinx is very uncertain. So it's hard to pin it down. Now, there was a paper recently which was talking about the level of the River Nile, and it placed a limitation on the age of the Sphinx based on it couldn't be that old because the level of the River Nile would have washed over the Sphinx had it been there and would eroded it away completely. So it had to sort of post-date the point when the Nile went down again. I haven't actually studied that paper very well, so I need to check out the details, but that would be a strong case against a much older Sphinx.
Interesting. Yeah, I'll have to check that out. Wow. Well, really exciting stuff, Dr. Sweatman. Thank you so much for coming on the show today. If listeners want to learn more about you and your research, is there a good website or something we can point them to?
My book, Prehistory Decoded, that summarizes the research up until a few years ago, 2019. My blog, martinsweatman.blogspot.com, has my sort of more recent ideas, including manuscripts for any papers that I've submitted recently. So check out my book and my blog, I would suggest.
Fantastic. Awesome. Well, thanks again for joining the show, and really appreciate the conversation. I hope you have a great rest of the day.
Thank you, Jordan. Nice speaking to you.
Yeah, absolutely.
Thank you all for listening, and I hope you enjoyed the episode. In this episode, we discussed the Younger Dryas YD period and the evidence supporting the impact hypothesis. Here is the abstract of Dr. Sweatman's 2021 Earth Science Review article reviewing the impact evidence. In 2007, a team of scientists, Firestone et al., proposed that a major cosmic impact, circa 10,835 calendar BCE, triggered the Younger Dryas YD climate shift, along with changes in human cultures and megafaunal extinctions. 14 years after this initial work, the overwhelming consensus of research undertaken by many independent groups reviewed here suggests their claims of a major cosmic impact at this time should be accepted. Evidence is mainly in the form of geochemical signals at what is known as the YD boundary, found across at least 4 continents, especially North America and Greenland, such as excess platinum, quench-melted materials, and nanodiamonds. Their other claims are not yet confirmed, but the scale of the event, including extensive wildfires and its very close timing with the onset of dramatic YD cooling, suggests they are plausible and should be researched further. Notably, arguments by a small cohort of researchers against their claims of a major impact are, in general, poorly constructed, and under close scrutiny, most of their evidence can actually be interpreted as supporting the impact hypothesis. That 2007 Firestone et al. Hypothesis proposed that one or more large, low-density ET objects exploded over northern North America, partially destabilizing the Laurentide ice sheet and triggering YD cooling. The shockwave, thermopulse, and event-related environmental effects, e.g. extensive biomass burning and food limitations, contributed to end Pleistocene megafaunal extinctions and adaptive shifts among Paleo-Americans in North America. Earlier this year, J.L. Powell published another paper highlighting the YD impact evidence and arguing that it had been prematurely rejected. On Substack, I've included Table 4 from Powell's paper, which shows the various impact markers at 56 Younger Dryas boundary sites across 5 continents. Powell highlighted the following impact markers. Black mat at 30 sites. Black mat refers to the stratigraphic marker covering the Clovis Age landscape of North America during the YD period. No Clovis sites are found above the black mat layer, and many extinct megafaunal species are found below the black mat, but not within or above. Impact spherules at 34 sites. Microspherules can be created by cosmic impacts, airbursts, and the non-catastrophic atmospheric burnup of small meteorites. Melt glass at 10 sites. Melted minerals above 1500 degrees Celsius strongly indicates production by a cosmic impact, especially in the absence of lightning and volcanism. Nanodiamonds at 26 sites. Nanodiamonds are nanometer to submicron-sized carbon crystals that are known to occur within meteorites and cosmic impact structures. PGEs at 38 sites. PGEs refer to platinum group elements like platinum, iridium, and osmium, which are much more abundant in meteorites than terrestrial upper crust rocks. And fire markers at 39 sites. Intense thermal radiation would be expected to ignite wildfires on the ground following a cosmic impact. Powell further highlights 6 major events that all occurred at or soon after the onset of the YD, approximately 12,850 years ago. 1. The Great Plumbing Shift of Glacial Lake Agassiz, a proglacial North American lake larger than the present Great Lakes combined. This shift occurred alongside destabilization of the Laurentide ice sheet. Lake Agassiz shifted from draining south down the Mississippi River, eastward through the St. Lawrence system, and northward down the Mackenzie River. 2. The flooding of the Mackenzie River. 3. Destabilization of the Fennoscandian ice sheet in Europe, resulting in a catastrophic flood of the Baltic ice lake. 4. The destabilization of the Greenland ice shelf. As geologist James Kennett notes, it is difficult to explain the triggering of such widespread synchronous changes at the margins of 3 relatively isolated northern hemisphere ice sheets, Laurentide, Fennoscandian, and Greenland, and the related proglacial lakes by invoking conventional climatic and/or paleoceanographic processes. Instead, this broad range of evidence is more readily explained by catastrophic processes triggered by a cosmic impact with Earth. The Younger Dryas boundary cosmic impact theory. 5. In North and South America, about 3/4 of megafaunal mammals became extinct at or near the Younger Dryas boundary. And 6. The projectile points crafted by the Clovis culture disappear from the archaeological record. The population of the Clovis people also underwent a major decline at the YD boundary. In addition to presenting the mounds of evidence supporting the YD impact hypothesis, both Sweatman and Powell took time to address the critics of the idea. They questioned why a small cohort of researchers have been so outspokenly critical of the hypothesis and why the broader scientific establishment latched on to their refutations despite the relatively weak supporting arguments. The abstract to Powell's paper reads, "The progress of science has sometimes been unjustly delayed by the premature rejection of a hypothesis for which substantial evidence existed and which later achieved consensus. Continental drift, meteorite impact cratering, and anthropogenic global warming are examples from the first half of the 20th century. This article presents evidence that the Younger Dryas impact hypothesis, YDIH, is a 21st century case. The hypothesis proposes that the airburst or impact of a comet about 12,850 years ago caused the ensuing about 1,200-year-long Younger Dryas YD cool period and contributed to the extinction of the Pleistocene megafauna in the Western Hemisphere and the disappearance of the Clovis Paleo-Indian culture. Soon after publication, a few scientists reported that they were unable to replicate the critical evidence, and the scientific community at large came to reject the hypothesis. By today, however, many independent studies have reproduced that evidence at dozens of YD sites. This article examines why scientists so readily accepted the early false claims of irreproducibility and what lessons the premature rejection of the YDIH holds for science. The scientists reporting that they were unable to replicate refers to an article by Nicholas Pinter and Scott Ishman titled Impacts, Mega Tsunami, and Other Extraordinary Claims. This article was published in GSA Today, a magazine for members of the Geological Society of America, which appeared just 4 months after the Firestone et al. Paper in January 2008. Their article starts, "Recognition of the importance of impact cratering ranks among the most significant advances in Earth and planetary sciences of the 20th century, but recently there has been a proliferation of reports of impact events and sites that eschew simple, less spectacular alternative explanations. Here we focus on 1. Holocene age ocean impacts and associated mega tsunami, and 2. A catastrophic impact event suggested at about 12.9 thousand years ago. Carl Sagan once said that extraordinary claims require extraordinary evidence. We argue that these impacts do not meet that standard." Powell goes on to sum up and dissect Pinter and Ishman's article, stating they presented no new evidence, appealed to irrelevant arguments, the mega tsunami and extraordinary evidence, and suggested processes to explain the abundance peaks that would have taken far longer than the decade or less that Hayes et al. Said was possible. A reasonable conclusion would have been to call for scientists to reserve judgment on the YDIH and to seek additional evidence. Instead of doing as Powell suggested, Pinter and Ishman had instead dismissively concluded their paper as follows. Both the 12.9 thousand years ago impact and the Holocene megatsunami appear to be spectacular explanations on long fishing expeditions for shreds of support. Both stories have played out primarily in the popular press, highlighting how successful impact events can be in attracting attention. The desire for such attention is understandable in an environment when science and scientific funds are increasingly competitive. The National Science Foundation now emphasizes transformative research, and few events are as transformative as an impact. In an era where evolution, geologic deep time, and global warming are under assault, this type of science by press release and spectacular stories to explain unspectacular evidence consume the finite commodity of scientific credibility. Consume the finite commodity of scientific credibility. Translation: if you have a theory that goes against the grain, you should shut up because proposing it somehow hurts the credibility of science as a whole. Of all the hyperbole in this closing paragraph, this statement grinds my gears the most. Scientific exploration and the capabilities of the human imagination are infinite, and anyone who says otherwise is no true scientist. In October 2009, a subsequent critical article by Survell et al. Was published in PNAS. Survell et al. Reported that they were unable to reproduce magnetic minerals and microspherules from 7 sites of similar age, including 2 examined by Firestone et al. Instead of recognizing that absence of evidence does not indicate evidence of absence, the authors concluded their report by writing, "Reproducibility is fundamental to the scientific method in hypothesis testing. Results that are not reproducible cannot be considered reliable or supportive of a hypothesis. In short, we find no support for the extraterrestrial impact hypothesis as proposed by Firestone et al." Power responded to the Survell et al. Paper by highlighting the flawed conclusion and ensuing damage this paper did to those supporting the impact hypothesis. It should have been obvious that Survell et al. Had not established that the YDIH microspheral evidence is irreproducible, only that they were unable to reproduce the evidence, for whatever reason. The possibility, if not the near certainty, that it was Survell et al. Who had erred should have caused scientists to reserve judgment about the YDIH. Instead, as shown in Table 2, right up to present day, many scientists have embraced the results of Survell et al. To cast doubt on the hypothesis. On Substack, I've included Powell's Table 2. This table lists 17 scientific publications between 2010 and 2021 that have cited the 2009 Survell et al. Paper as justification for dismissing the YDIH. For example, a 2011 paper by Holliday et al. Extended these flawed conclusions by stating, "All attempts to test and replicate this claim or to confirm aspects of this hypothesis have not been successful, raising serious concerns about the veracity of the claim." Now, I understand the merits of peer review and that everyone should exercise healthy skepticism. I also agree with Carl Sagan's argument that extraordinary claims require extraordinary evidence. Yet I also question, at what point do we see a trade-off? Does forcing our thinking into the rigid models of our predecessors limit the unbounded nature of our imagination? Could fearing the ridicule of our peers after proposing something novel cause us to self-censor the next great idea? The YD impact hypothesis, like the Alvarez theory on dinosaur extinction 40 years before it, has taught us that we barely know anything about the nuanced, mysterious history of our planet Earth. But isn't that also the fun of it? Science is meant to be an exploration, an expression of the human pleasure in figuring things out. When scientism instead becomes a tool of orthodoxy, groupthink, and condescension against free thought, it has devolved into a different phenomenon altogether. But putting those philosophical questions to the side, researchers like Sweatman, Powell, Firestone, and others have done an excellent job compiling the evidence in support of the Younger Dryas impact hypothesis, helping us to dust off the lingering remnants of gradualism and embracing catastrophism once and for all. As Dr. Sweatman highlights, probably with the YD impact event essentially confirmed, the YD impact hypothesis should now be called a theory. Powell agreed, noting that a scientific theory is a well-substantiated explanation of some aspect of the natural world based on a body of facts that have been repeatedly confirmed through observation and experiment. It refers to a comprehensive explanation of some aspect of nature that is supported by a vast body of evidence. One of the most useful properties of scientific theories is that they can be used to make predictions about natural events or phenomena that have not yet been observed. Those who have read this article in Sweatman's have the information to decide whether the YDIH meets this definition. In this author's opinion, there is a strong case that it does. Moreover, it should not be forgotten that no other single theory can explain the YD and its associated effects. The Younger Dryas impact theory, folks. That has a nice ring to it. What do you think?